The most hyped tech skill of the decade is officially dying. This video breakdown examines analyst WhyPratiik's provocative thesis that rapid AI evolution has made complex, manual prompting increasingly obsolete. By the end of this video, you will understand exactly why prompting is fading, what is replacing it, and why the future of working with AI looks less like writing increasingly elaborate instructions and more like designing intelligent systems around the outcome you actually want. But to understand where we are going, we first have to uncover a hidden design flaw in early large language models that forced us to become prompt engineers in the first place. When ChatGPT first burst onto the scene in late 2022, we were suddenly handed an incredibly powerful engine, but it arrived without a steering wheel, a dashboard, or a fuel gauge. Those early large language models were fundamentally stateless. If you sent a query to a model, it had absolutely no memory of the prompt you sent 5 seconds earlier. It could not plan 5 steps ahead. It had no access to external databases, live calculators, or web browsers. It was a massive, isolated mathematical prediction engine, frozen in the year its training data was collected. This created a massive friction point for anyone trying to get real work done. If you wanted the model to write code in a specific style, analyze a financial sheet using a particular framework, turn an interview into a polished article, or restructure a long report into something useful, you had to manually cram all of that context into the prompt window every single time. Prompt engineering emerged not as a permanent new career path, but as a temporary, manual scaffolding designed to prop up these incomplete systems. We use natural language to inject context, force step-by-step reasoning, specify formatting, establish roles, describe the audience, define the tone, dictate the structure, and explain exactly how the machine should approach the task. We were essentially acting as the external memory and cognitive coordinators for an engine that lacked its own internal infrastructure. To appreciate how fragile this setup was, we have to look at how these early models processed our elaborate prompts. The process relies on what computer scientists call in-context learning. When you wrote a massive prompt that began with a complex role-play scenario, followed by 5 examples of how you wanted the output formatted, and finished with a set of strict rules, you were not actually teaching the model anything new. You were simply using your token budget to steer the model's attention mechanism toward a specific subset of its pre-existing training data. The model was not learning. It was simply being mathematically constrained by your prompt. If you changed a single word or even a comma, the attention weights could shift, sometimes causing the output to fall apart. This is why late 2022 and early 2023 saw an explosion of online threads claiming to have discovered the perfect prompt formula. People were treating large language models like magical black boxes that required precise incantations to operate. My take is that we mistook a temporary user interface limitation for a permanent new discipline. We were writing long, highly specific procedural instructions because the models themselves lacked the autonomy and surrounding software infrastructure to figure out the best way to solve a problem. And once you recognize that, an interesting question appears. Why should the user have to become an expert prompt engineer in the first place if you already have the source material, whether that is a report, an interview, an article, a lecture, a screenplay, or a transcript? Why should transforming that information into something useful require opening a blank chatbot, constructing a giant prompt, explaining the source, describing the output, defining the tone, specifying the audience, correcting the structure, and then repeating half of that process when the first result is not quite right? That is exactly the kind of friction that a different generation of AI software is starting to remove. Narratora, a generative content automation platform, is built around that source-first approach. Instead of beginning with an empty prompt box and forcing the user to describe the entire workflow manually, you give the platform the source material. Narratora analyzes what kind of material it is, recommends an appropriate workflow, and lets you choose the professional output you actually need. So an interview can become a voice-ready YouTube script, a research paper can become a blog article, a 200-page report can become an executive brief, lecture material can become a structured study guide. The important shift is not simply that AI writes the final document, the workflow itself moves into the software. Narratora's smart source detection attempts to identify what kind of material you supplied and recommends an appropriate workflow. Then its creator control layer lets you choose things like length, tone, audience level, and output format without turning those decisions into another massive prompt. The philosophy is simple: source, intelligence, workflow, professional output. That is a small example of the larger transition happening across AI right now. Instead of expecting humans to constantly explain the process in increasingly elaborate natural language, the process itself is becoming part of the system. Think about it this way. If you hire a junior developer, do you sit next to them and dictate every single keystroke, variable name, and logic branch? Of course not. If you have to do that, you are not actually leveraging their talent. You are just using them as a human keyboard. That is exactly what early prompting was. It was cognitive micromanagement. We were so amazed that a machine could generate coherent text at all that we happily spent hours tweaking adjectives, adding triple backticks, assigning fictional expert roles, and pleading with the system to think step by step. But as these systems scaled, this manual handholding began to hit a wall of diminishing returns. The primary reason prompt engineering is breaking down today is that more of the intelligence has moved inside the model itself. WhyPratiik points out a crucial shift. Modern large language models increasingly do not require us to tell them how to think in the same painstaking way. In the early days, if you wanted a highly structured professional system architecture design, you might write a paragraph instructing the model to act as a senior software architect with 20 years of experience at a major enterprise tech firm. Today, if you simply ask a capable frontier model to design a scalable backend for a product, it can often infer the appropriate role, depth, structure, and tone. It knows that a scalable backend design may require discussion of load balancing, database replication, caching strategies, API gateways, security, and failure recovery. It does not necessarily need you to prime its attention weights with a fictional biography. The model has internalized more of the semantic relationship between the goal and the professional standard required to achieve it. This internal evolution reveals a deeper technical truth that many prompt builders are slow to accept. Longer and more complex prompts can become an active liability. In the early phase of generative AI, the dominant philosophy was that more instructions naturally equaled better output. We built enormous system prompts filled with edge case handling, formatting constraints, tone instructions, examples, prohibitions, and reasoning guidance. But overloading a model with instructions can also introduce semantic noise. When you crowd the context window with dozens of competing constraints, the model's attention mechanism has to distribute its mathematical weight across a massive web of instructions. And some of those instructions inevitably compete. Tell a model to be creative, but highly structured, concise, but incredibly thorough, conversational but deeply technical, emotional but neutral, and to obey 10 different formatting rules. And the system has to make trade-offs. The result can become sterile, compromised, or strangely mechanical. My take is that by trying to over-engineer every stage of the reasoning process, we sometimes prevent the model from utilizing the capabilities that made the newer system more intelligent in the first place. The model may already be better at reasoning through parts of the problem than the person attempting to prescribe every step. Have you ever tried to complete a task while someone stood over your shoulder constantly shouting conflicting directions? That is what a 3-page prompt can feel like to a modern model. Instead of allowing the neural network to find an efficient path toward the objective, we force it to jump through a series of linguistic hoops designed around assumptions that may have been necessary 2 years ago, but are becoming less necessary today. And the issue becomes even more obvious when we leave the chatbot window and start thinking about real software. Beyond the cognitive limitations of the models themselves, there is a massive practical roadblock that prompt engineering simply cannot overcome. Prompts do not scale to real-world software systems. A static prompt works beautifully in a controlled demo, a clean tutorial, or a simple one-off task. You paste a block of text into a playground, get a nice output, and share it. But when you try to build an enterprise-grade application that handles thousands of unique user queries every minute, that static prompt becomes incredibly fragile. Real software systems do not operate in a vacuum. They require persistent memory across days or weeks, the ability to dynamically call external APIs, the capacity to execute multi-step reasoning chains, permissions, guardrails, state management, and robust error recovery mechanisms when things go wrong. If an API call fails or returns unexpected data, a static prompt cannot independently rebuild the surrounding application logic. It cannot reliably decide when to pause, search for an alternative tool, retry with different parameters, or escalate the problem unless those abilities have been designed into the system around it. In a production environment, relying on a fragile string of natural language to control your application's entire logic is a recipe for instability. One slight shift in a model's behavior after an update could break an output format and send bad data into the downstream pipeline. This brings us to a major turning point in how we build with AI. If static prompts are too fragile for real systems, and over-constrained instructions can hurt performance, how do we build reliable, complex applications? The answer lies in a complete paradigm shift. We are moving away from writing prompts and toward designing intelligent systems. This is the transition to agentic AI. WhyPratiik frames this as a shift from talking to AI to building AI systems. To understand that, we have to look closely at what an AI agent actually is and how it differs from a simple query and response model, because this is where the real value starts moving. But first, quick pause here. Like the video, subscribe to the channel, and then let's pick this back up. An AI agent is not just an LLM sitting inside a chat window waiting for your next instruction. It is a software design pattern that wraps a core language model in an active execution loop. While a traditional prompt response system is largely passive, where you ask a question, receive an answer, and the process terminates, an agentic system can be given a higher level goal and equipped with the infrastructure required to work toward that goal. WhyPratiik outlines the core capabilities that define this new default. An agent understands goals, breaks them down into specific tasks, decides on actions, uses external tools, stores memory, evaluates outcomes, and iterates. This is a massive leap forward. Instead of writing a complex, three-page prompt trying to guide a model through a multi-step data analysis, you build an agent. You give that agent access to a Python execution environment, a SQL database, and a file system. You tell the agent, analyze this dataset, and find the three most important trends. The agent does not have to stop at generating a text block. It can inspect the schema, write code to process the data, decide which statistical methods are appropriate, execute the code, examine the results, detect an error, revise the code, run it again, and then present a structured explanation of what it found. The user never needs to see most of the internal instructions that make this happen. They become part of the architecture. That distinction matters. Prompts are not necessarily disappearing from AI systems. They are moving downward in the stack. To understand how this works under the hood, let's examine one of the design patterns that helped popularize this way of thinking, ReACT, which stands for reason and act. In a ReACT-style loop, the underlying language model receives information, reasons about what should happen next, takes an action through a tool, observes the result, and then uses that observation to determine the next step. Suppose the model realizes it needs a specific financial metric. The action phase might query an external API. The observation phase takes the return data and places it back into the model's working context. The system then decides whether it now has enough information to answer the request or whether another action is necessary. By wrapping the model in a continuous feedback loop, we solve part of the one-shot problem that defined early prompting. The model does not need to get everything right in a single massive forward pass. It can encounter a limitation, retrieve additional information, use another tool, evaluate what happened, and continue. That shifts the engineering challenge entirely. We are no longer obsessing exclusively over the perfect, all-knowing prompt. Instead, we are building the digital infrastructure, the tools, memory systems, permissions, evaluation layers, and guardrails that allow an intelligent model to safely navigate its environment. Think of the difference between an old-school autopilot system and a self-driving car. An old-school autopilot holds a heading and altitude. If circumstances change outside the conditions the system was designed to handle, a human has to intervene. A self-driving system is constantly perceiving its environment, mapping obstacles, calculating alternative paths, and adjusting its steering and speed. That is the conceptual leap from static prompting toward agentic systems. We are trying to build systems that can navigate messy, unpredictable, real-world information without crashing the moment they encounter an unexpected input. This transition introduces a fundamental shift in how we interact with computing systems, the move from procedural instructions toward declarative goals. Historically, programming has been deeply procedural. If you wanted a computer to do something, you had to describe exactly how to do it. You defined loops, conditional statements, data structures, functions, error handling, and every important step in the execution path. Early prompt engineering was still heavily procedural. We were writing long recipes in English. Do step 1, then step 2, then analyze this, then compare that, then format the answer exactly like this. WhyPratiik argues that the emerging approach is increasingly declarative. In a declarative paradigm, you describe the desired outcome and allow the underlying system to determine more of the execution path. Think about SQL. You do not normally write code explaining how the database should physically traverse files on a drive, which index pages to open first, or how bytes should be compared in memory. You write something closer to a statement of intent, return the customers who meet these conditions. The database engine determines how to execute the query. AI is moving in a similar direction. You do not necessarily tell an advanced system how to search, how to reason, how to compare every result, or exactly which tool it must use at every stage. You define the objective, and the agentic architecture coordinates more of the execution. That is why the Narratora example matters beyond content creation. Its source-first workflow is a narrower version of the same design philosophy. The user does not need to explain every internal step required to turn a 2-hour interview into a YouTube script or a large report into an executive brief. The user supplies the source, chooses the outcome, adjusts the relevant creator controls, and lets the workflow coordinate the transformation. And because the generation remains anchored to user-supplied source material, the system is designed to reduce source drift rather than asking the model to freely invent the underlying information. That does not make AI infallible, and important facts still need verification, but the architecture changes the user's job. Instead of micromanaging syntax, the user directs intent. That is the larger transformation happening across the industry. When natural language becomes a true high-level interface rather than a fragile programming hack, the way we build software changes forever. In the past, writing natural language prompts was treated as a way to trick the model into behaving almost like a compiler. we were trying to use English to achieve the deterministic precision of a language like C++ or Python, that was always going to be difficult, because human language is inherently ambiguous, context-dependent, and fluid. But when we treat natural language as an interface for expressing high-level intent, its flexibility becomes a strength rather than a weakness. We can state goals in broader conceptual terms and allow the underlying architecture to translate those goals into precise actions. The agent can use tools to interact with database schemas, compile code, access files, run tests, retrieve information, or manipulate structured data. Natural language becomes the bridge between human intent and machine execution, rather than the entire execution system itself. My take is that this represents a kind of democratization of system architecture. The value is no longer locked up in knowing the secret combination of words that makes an LLM behave properly. The value is increasingly in knowing what should be built, what information the system needs, what tools it should have access to, what restrictions should exist, how success should be measured, and how the final result should be verified. But let's be honest here. If we are not spending our days writing giant prompts, what are we actually doing? If the skill that everyone rushed to learn is becoming less central, what does a modern AI developer or power user actually do all day? The answer is that the value has moved up the stack. WhyPratiik identifies a specific set of skills that define this post-prompting era: AI system design, agent orchestration, tool integration, memory management, and evaluation frameworks. Let us break these down because these are the skills that could define the next decade of technology work. The first is agent orchestration. This is the art of connecting multiple specialized capabilities into a cohesive workflow. Instead of trying to build one giant all-knowing agent that handles everything from customer support to database management, we can build networks of specialized agents or components. You might have a planner that breaks down a user's request, a researcher that retrieves relevant information, a writer that drafts the response, and an evaluator that checks whether the output meets the required standard. Orchestration is the process of managing communication between those components, deciding when control should move from one to another, and ensuring that context is preserved as information travels through the pipeline. In some ways, it looks less like writing a magical prompt and more like designing an organization. You define responsibilities. You establish communication standards. You determine what each component is allowed to do. You define the handoff procedures. And you determine what happens when something fails. The second critical skill is tool integration and memory management. Language models become dramatically more useful when they can interact with the environment around them. To make an agent genuinely useful, you have to build bridges connecting it to the real world. That might mean APIs that let the system query a database, retrieve a document, send an email, execute code, access a calendar, or search external information. But giving the system tools is only half the battle. You also have to manage memory. A useful agentic system may need to know what happened in previous interactions, but it cannot simply append every conversation the user has ever had into a context window forever. Eventually, the context becomes enormous, expensive, noisy, and difficult to reason over. This is where retrieval systems, semantic search, databases, summaries, and different forms of memory architecture become important. As an AI system designer, you have to decide what information should be stored, how it should be represented, when it should be retrieved, how long it should remain relevant, and what should be discarded. You are effectively building a cognitive filing system for the machine. What deserves permanent storage? What belongs in short-term working memory? What should be retrieved only when the current task makes it relevant? And what should never be stored at all? Those questions are much more important than finding a clever synonym that makes a chatbot produce a slightly better paragraph. The third and perhaps most overlooked skill is the development of evaluation frameworks. When you move away from deterministic software and toward probabilistic AI systems, testing becomes incredibly difficult. You can no longer assume that an input of X will always produce exactly the same output Y. These models can solve the same problem in several different ways across several different runs. That means evaluation has to become more sophisticated. One technique involves model-based evaluators, sometimes called LLM as a judge, where another capable model scores an output against predefined criteria. Evaluation systems can also run automated simulations, measure whether specific requirements were satisfied, test tool use behavior, compare results against known answers, monitor failures, and identify behavioral drift after a model or system change. Imagine updating one component inside a multi-agent workflow. How do you know that change has not caused a failure 5 stages downstream? You need regression testing. You need representative scenarios. You need failure cases. You need metrics. And you need monitoring. Alongside this technical challenge, domain expertise becomes more valuable than ever. If you do not understand the domain you are building for, whether it is healthcare, finance, law, filmmaking, education, software engineering, or professional writing, how can you define what a good result actually looks like? How do you know which mistakes are harmless and which are catastrophic? How do you know what should be verified? How do you know what an evaluator should reward? You cannot build a reliable AI financial analysis system if you do not understand what competent financial analysis looks like. You cannot design an AI legal workflow responsibly if you have no idea how legal professionals evaluate evidence, authority, jurisdiction, and risk. You cannot create a strong screenplay analysis system simply by telling a model to act like a professional script reader if the surrounding workflow has no clear framework for narrative evaluation. The future belongs to people who can combine domain knowledge with intelligent system design. Now, does this mean prompts are completely dead? No. And this is where WhyPratiik offers one of the most useful analogies in the entire argument: SQL and Object Relational Mappers, or ORMs. When ORMs became popular in software development, they allowed developers to interact with databases through their normal programming language without constantly writing raw SQL. Some people assumed this meant SQL would disappear. It did not. SQL became a lower-level tool that developers could still use when necessary. Most developers might use the ORM for routine operations because it is faster, cleaner, and easier to maintain. But when they hit a difficult performance bottleneck, a complex migration, or a highly optimized query, understanding the underlying SQL can suddenly become extremely valuable. That is a much better way to think about prompting. Prompts are not disappearing. They are becoming shorter, more focused, more dynamic, and increasingly embedded inside the systems themselves. The average user may write fewer 3-page prompts in a blank chat window. Instead, they will interact with applications designed around specific goals and workflows, while the underlying software uses prompts internally as one part of a much larger architecture. That is exactly why platforms built around predefined workflows are interesting. In Narratora, for example, the user does not need to manually recreate the logic of a document breakdown workflow every time they upload a report. They do not have to keep a giant prompt explaining how a spoken interview should be transformed into a voice-ready YouTube script. They do not have to rebuild an audience, tone, length, and output framework from scratch every session. Those decisions are increasingly becoming interface controls and workflow logic. Prompts still exist underneath. They are simply no longer the star of the show, and that is probably the best description of where prompt engineering is heading. It is becoming the low-level assembly language of the cognitive era. Useful, powerful, sometimes essential, but increasingly hidden from the person simply trying to accomplish a task. So what is the ultimate takeaway here? If you spent the last few years collecting prompt libraries, memorizing cheat sheets, experimenting with role prompting, learning how context affects outputs, and trying to master the perfect phrasing, that knowledge was not useless. Those skills taught us how language models respond to context. They taught us how instructions compete. They taught us how examples steer behavior. They taught us why ambiguity matters. And they helped millions of people build an intuition for how these systems work. But now the abstraction layer is changing. The question is moving from what is the perfect prompt to what is the goal? What source information does the system need? Which tools should it use? What workflow should coordinate those tools? What memory should persist? What guardrails should constrain the system? And how will we know whether the result is actually good? WhyPratiik's central insight is reassuring. Prompt engineering is not fading because generative AI failed. It is fading because parts of generative AI are beginning to work more like we originally hoped they would. We are leaving an era dominated by fragile manual syntax and moving toward an era where intent matters more, workflows become smarter, and natural language increasingly serves as the interface between human goals and machine intelligence. You can already see that philosophy appearing in focused applications. With Narratora, a generative content automation platform, the idea is not to make you become better at writing giant prompts. It is to let you start from the material you already have and turn that source into the professional output you need through a structured workflow. One source. Multiple professional outputs, no complicated prompting. If that kind of source-driven workflow fits the work you are doing, you can try it at narratora.com. But the larger lesson goes far beyond any one platform. The real opportunity is no longer simply learning how to talk to the machine. It is learning how to design the intelligence, workflows, tools, memory, and evaluation systems that allow the machine to do useful work. As we move deeper into this agentic future, the ultimate question will not be how cleverly you can phrase an instruction. It will be how effectively you can define the objective and design the system that executes it. If you made it this far, you're the reason I make these. Like the video and subscribe to the channel, and I'll see you in the next one.